Lesson number 20, the derivative. Now, in a typical calculus class, this would probably be one of the first major lessons of that course. Of course, this is pre-calculus, hence things to prepare you for a calculus class should you choose to take it. So on lesson number 19, we talked about something called the difference quotient, defined to be the limits as h approaches 0 of x plus h minus f of x all over x. There's a name for that, as I just said, the difference quotient. But another name for it is called the derivative of a function f of x. Now, if you notice this weird notation right here, f apostrophe x, of course we don't call that apostrophe. We call that little apostrophe prime in the world of mathematics. Prime. It's kind of like f inverse of x that has its notation. If you have f of x versus f inverse, the way we notate that, I'm going to bring that on the screen now. Okay. But of course, now we're talking about these types of we're talking about the derivative. So let's recap, or at least review once again, how to find the derivative. But let's rephrase the question, or find the difference quotient. I'm going to rephrase the question. Find the derivative. Derivative. Even filming this, I still can't spell. Derivative of f of x. So, let's say f of x is equal to, let's make something a little bit more difficult. X squared plus 3x minus 4. Okay? That might have been on your homework last night, something like that. And we want to find a derivative. But hey, right above there, it says it's the same thing as the difference quotient. Okay, so let's go ahead and use what we learned so far. Now, for those of you who have learned calculus before, please don't spoil what's about to happen or what am I actually indicating for. Anyway, so what we're going to type is, instead of x squared plus 3x minus 4, as defined by the derivative, or excuse me, difference quotient, it's going to be f of x plus h. It's no longer just x. So instead of x squared plus 3x minus 4, I'm going to write parentheses x plus h squared plus 3. You're supposed to fill into yourself what's next. You probably said, I hope, parentheses x plus h minus 4. Basically, this x has been replaced with x plus h minus. Again, there's a big fraction all here, what you should have done on last night's homework. Minus, so again, we're following this. This is f of x plus h right here, minus this big f of x, which I'm going to literally plug this thing all the way over here. Now, to be super safe, I like to put, I'm doing it in pen too, x squared plus 3x minus 4. Boom. All over h. Wow, my definition was wrong the whole time. How come no one told me? So sorry. Not all over a x, it's all over h. Thank you for correcting me. I know some of you are like, Mr. Viernes, it's supposed to be x, h, not x. Okay, anyway, all over h. My bad. Okay, then the goal was to go ahead to try to multiply everything else to see if things would cancel. So I rewrite the limit again. I'm going to multiply this out because I know how to multiply that out in my head now. That is x squared plus 2xh plus h squared, distributing the 3x plus 3h minus 4 minus x squared minus 3x plus 4. Again, I distributed this negative here, here, and here. And then again, this is all over h. Once again, the goal is to plug in 0 for h. Right now you can't, because we get something undefined there. But if we did this correctly, things should start to cancel. We got these guys. We got hey. And all we have left is the limit as h approaches 0 of 2xh plus h squared plus 3h. That's it. All over h. Cool? However, you still cannot plug in h and 0. So basically, one thing you could say is that our goal is to somehow cancel this h. Because then, by canceling this h, it'll allow us to go ahead and plug in h as 0. Because we can't do it now, because it makes the function undefined. However, you should notice that all three of these have an h. And you can only do these when all three of them have an h. And all we have left is the limit of h approaches 0 to x plus h plus 3. And that is it. Much more easy. Now, what we're going to do now is plug in h as 0, and our derivative or difference quotient is 2x plus 3. Boom. So you might be asking, Mr. Viernes, what the heck is the difference? I mean, why do you have two separate lessons for doing the same thing? Ha. Okay. Now, there is another name for this. We are calling it the difference quotient. We're also calling it the derivative. But also, we're also calling it something called the slope formula. Why do we care about something called the slope formula? Well, here we go. Okay. Again, this is more into the calculus part of calculus. So, why do we care about this something called a slope formula? Well, let's pretend for a moment we have a function. In the world of calculus, what we care about is how fast is something going at a specific time. Now, what that means is, let's say this is the traveling of a ball. The ball goes up in the air, and it goes down. Now, if we want to, for instance, figure out how fast is the ball traveling at that point, we're basically asking if this is a point and I draw something called a tangent line, the slope of this tangent line is basically how fast at this point in time. Now, basically it'd be going up to and right at that, whether this would be time, and we can call this distance. It can have other applications, but the most basic application of this scenario is the fact that we're talking about time and distance. And we know distance over distance times time is speed. Am I getting that wrong right now? Either way. Oh yeah, distance over time equals speed. So that basically the slope of this tangent line that touches that point is going to be how fast it is at that time. So, what would be the slope if I drew a tangent line right here? What's the slope of this line if I want to know how fast is this ball right at that point in time? How fast is it moving? If you said 0, you'd be correct for two reasons. One, look at that. It's a horizontal line. We know the slope of horizontal lines are 0. Also, the ball's not moving at all. At that point in time, it had reached its highest distance, and it's going super slow. And I mean super slow. It's not moving at all at that specific amount of time. And then it goes back down. As you can see, these have positive slopes, which means it has a positive speed because the ball's going up. Now, it makes sense then, these have a downward slope as the ball's going down. Whether it's going up speed or positive speed or negative speed, depends on the ball's going up or down. Now, that's fun and games. But what if I told you, well, what calculus cares about is how fast are all of these lines here. These are called tangent lines. If you did catch that, tangent lines. Now, what if I told you that there is a formula that always gives us the slope of each of those tangent lines as long as we know what point in time we're talking about? Slope of all tangent lines given any x. We call that the derivative. This magical formula or magical concept is a formula that gives us every single slope no matter what given point in time. So let's go back to that original equation. That original equation we talked about once again was x squared plus 3x minus 4. Okay? A typical calculus question would be first find f prime of x, which we know already. It was 2x plus 3. And then you can ask how, if it represents a ball, for instance, how fast, or actually, what is the slope of the tangent line at x is equal to -4. Normally you could just draw the picture and then draw the tangent line and try to see. I mean, I think the graph looks like this. Please don't quote me on it. And we basically want to know what is the slope right here all the way at -4. However, we don't need to do that. We don't need to draw it. We have a formula that gives us all of our slopes. So the slope is basically figuring out what is f prime of -4. Just plugging in -4 into our formula gives us 2 -4 plus 3. This gives us -5, which actually makes sense. Look how steep that slope is, and it's a downward slope. At -4, it's going down -5/1. This is the slope. Again, as to more why that is important, we honestly don't want to get too much into it, but when it comes to very complex calculus problems, they really care about those applications of how fast things are going. That's why when you take AP Physics, I believe you need to either take concurrently AB Calc or Pre-Calc maybe. I'm actually not sure. I think AB Calc, BC Calc. Because you need to know how to find something called the derivative. So, you're thinking to yourself, gee, this is all fun and games, but Mr. Viernes, it takes so freaking long to find the derivative. It sure does. However, there is a secret shortcut. And be like, why is he doing the DQ when he could just do the shortcut? Well, when I usually have students in the class, I try to determine who can actually see what the derivative is, who could see the shortcut just by looking at it. So I'm going to do some functions. Here's x squared. Its derivative. Again, I'm not going to tell you the shortcut. I want to see if you could figure out the shortcut. Its derivative is 2x. Okay. How about if f of x is 3x to the third? Its derivative is 3x. Some of you might thinking, oh, just 3x. Nope. 3x squared. Here's a huge hint. This is not just 2x. This is actually 2x to the first power. I'm going to pause for a second to see if you could see what the pattern is. Okay. How about f of x is equal to x to the fourth? Its derivative is, I have to write down here. Did you just say 4x to the third? And I'm wondering why I'm talking like this? Oh, it is 4x to the third. Yes. Okay. Do you know the pattern yet? Now, you might be wondering, do I not need to know how to use the difference quotient anymore? Well, this shortcut only applies to polynomials only. So f of x, let's go 2x squared plus 3x. The derivative is going to be 4x to the first power plus 3x to the 0 power. Now, you should know that anything to the 0 power is just 1, so my derivative is actually 4x plus 3. Do you see the pattern yet? Feel good that you have seen it and you know what it is and you are awesome. That doesn't mean those who haven't figured it out yet are not awesome. Some from people it takes a little time, some people just need to know what it is. But once you're told what it is, or at least you figure it out, it really is super meaningful. Let me do one more to see if you could figure out what the secret super shortcut is. Now, you might be wondering again, well, I'm always going to use the shortcut, Mr. Viernes. Ha! But on a test or quiz, you might be running into two issues. One, again, it's polynomials only. If the function I give you is not a polynomial, you cannot use this shortcut. Two, if the freaking problem says use the difference quotient, which is this definition back there, you cannot use the shortcuts. If it doesn't say don't use the shortcut, use the shortcut as much as you want. Anyway, f of x, let's go 3x to the fourth plus 2x to the third minus x squared plus 100. Oh boy. Okay. The derivative is, let's go one by one, slowly. I'm going to let you say it, and then I will say it. The derivative is 12x to the third plus 6x to the second minus 2x to the first plus, ooh, this is tricky. I don't know if you know what it is, but for 100, well, there's kind of two ways to figure this out. Here is one way. Pretend for a moment there is an x to the 0. Why? Because, well, x to the 0 is just 1. So using the pattern, if you figured it out, this is going to be 0. So my derivative is f prime of x equals 12x to the third plus 6x squared minus 2x. These are all slope formulas. Slope formulas. Okay. Here is the shortcut. What we're doing is the derivative of anything. If you have f of x equals this, what's happening is the n drops and multiplies times the coefficient, and the new numerator subtracts by 1. That's my shortcut. So when it comes to these, I'm basically applying the shortcut to each term in the polynomial. So I subtract this by 1 to get x to the first, and the 2 drops. So basically, this n is dropping to multiply to whatever coefficient is there, and it subtracts by 1. Now, you might be wondering, well, why is it that if I take the derivative of, I don't know, 100, it just gives me 0? Well, the other reason is, other than the fact that pretend there's an x to the 0 here, you're basically, I'm basically asking you, what is the slope of a number? If f of x equals 5, for instance, if I graph that, it's just a horizontal line. What's the slope of a horizontal line? 0. So we can make a note. For f of x equals a is any number for the horizontal function, horizontal line, the derivative is always 0. If that helps at all. Okay. All right, that should be that should be the end of lesson number 20. This is a lesson that should have occurred over 60 to 90 minutes. But of course, I'm by myself in my kitchen. So please, you don't have to like or subscribe, but definitely wash your hands. And please don't forget to do homework. This is Mr. Viernes signing out.